When we introduced the mole concept, we said, as a chemist, you would want to know the amount of molecules that are needed for a reaction to occur. You want to know so that you do not use too much such that you waste your reagents, or you want to know such that you do not use too little and you end up not getting the actual products. But when we were doing that, we only focused solely on one compound, and we focused on one element in that compound. But what usually happens is that a reaction occurs in more than one compound in a form of a chemical equation. So when you want to know the amount of any substance that occurs in a reaction, what you would want to know, you'd want to find that amount in relation to other chemicals or other compounds or molecules that are usually involved in a reaction. So that concept of relating amounts of molecules involved in a chemical reaction is called stoichiometry. Have we started? No?
Let's go. This is for every child that wants to make it one day. Izimbo class and presence of mind is elsewhere. Cinga uzudlani afuna kuhle already alisibani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the reason and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
What's up, everybody? Welcome back to yet another episode of Basic CHEM 101 with Sihlebonani. My name is Sihlebonani. I've already told you what we'll be doing. So what I need from you right now is to subscribe and press the bell button so that we can continue forward. Let's go. Okay, now that you have subscribed, let's go back to stoichiometry. Stoichiometry is actually a calculation of reactant and product quantities which are involved in a reaction. That is stoichiometry, basically. So, for us to understand this thing, let's talk about something that we already know and base it to what we are trying to understand right now. So what we know is if you burn acetic acid in oxygen, you'd get water and carbon dioxide. So if you already know this thing and for some reason you want to produce carbon dioxide and you want to, let's say your carbon dioxide is 6.21 milligrams. Now you want to produce 6.21 milligrams of carbon dioxide. That's all you know. But you know that if you react acetic acid and oxygen, you would get your carbon dioxide. Now, the type of questions that you would ask yourself is that, how much of acetic acid do I need in order for me to produce 6.21 milligrams of carbon dioxide? Or how much of oxygen do I need in order for me to produce 2.61 milligrams of carbon dioxide? Now, the answers to such questions would lie in your equation and in your balanced equation. Remember how to balance your equation? So you'll have to balance your equation first, which is here. You look at an atom which occurs once on both sides. Let's say this is carbon, this is carbon. So we look at carbon. So there's two carbons here, there's one. So 2 here. Then there's 4 hydrogens, there's 2. And then 2, 4 oxygens, 2, 6 oxygens. So I'll need 2 here. So I have my balanced equation. Now, I have to be able to interpret my balanced equation in terms of moles, what you would call your molar interpretation. So if I interpret this thing, it means one molecule of acetic acid and two molecules of oxygen gives me two molecules of water and two molecules of carbon dioxide. Or I can stretch it further to say 1 mole of acetic acid and 2 moles of oxygen gives me 2 moles of water and 2 moles of carbon dioxide. So if I can be able to interpret my equation like that, I can use that interpretation in order for me to calculate the mass that I am looking for, which is the mass of acetic acid. So if I want to know the mass of acetic acid needed to calculate to produce 6.21 milligrams of carbon, I can use this interpretation and calculate the mass of acetic acid. So I'll have to calculate, I'll change this to moles first. So this is 1 mole of carbon dioxide is 44 grams of carbon dioxide. This is your molar mass. And then I have my moles for carbon dioxide. Now I have to relate these moles based on what I was saying. So I was saying 1 mole of acetic acid is equal to 2 moles of carbon dioxide. Now I have moles for acetic acid, and then for me to get the mass, I'll have to multiply by molar mass. So 60 grams of acetic acid would be equal to 1 mole of acetic acid. Then you have your mass, which is your mass would be round about 4.23 times 10 to the negative 3 grams. This is 4.23 milligram of acetic acid. So that is actually how you would calculate the mass of acetic acid if you know the mass of the product that you want. But sometimes you'd be asked, if you have 2.43 milligrams of acetic acid, how much is the mass of oxygen that can react with this mass? So if you want to know that, you'll always have to change first your acetic acid to your number of moles of acetic acid. Then once you have your number of moles of acetic acid, you relate it to the moles of oxygen. So your 1 mole of acetic acid is 2 moles of oxygen. Then once you have that, you have to multiply by your molar mass of oxygen. But now this is oxygen gas, so you multiply by 32 grams of oxygen is 1 mole of oxygen. Then you get your mass of oxygen, which is 4.51 milligrams. This is usually an ideal situations. This is how you can relate the quantities of the molecules involved in a reaction in an ideal situation. But it happens that you don't usually add the exact amount. One amount would be higher than the other and one would be less. And then what do you do in those situations to get to your product? We will talk about that in the next video when we talk about limiting and excess reagents in a chemical reaction. Otherwise, for now, I think it's best to stop there and you can do your practices in trying to understand and relate molecules in a chemical reaction. Once you are able to do that, we can be able to move on to the next step. For now, please like the video if you got something out of it. Also, please subscribe if you didn't when we asked you to last time. Also, please share so that we can help someone else to understand what we are talking about. Otherwise, thank you very much for watching. This has been Basic Chem 101 with Sihle. My name is Sihle. I'll see you next time. Thank you very much. I'm gone.